Okay, we have discussed in the last class how you can interface the LEDs with the microprocessor. Okay, so just to revise, so we have taken a NAND gate, which the input of all these NAND gates were connected to A0 to A7. So it gives a unique address pulse, that is logic 0, and all the input are at logic 1. So it was the address of the device was fixed using this circuit, which is FFH. Okay, and then you have input output write command from the processor. When both these signals they get activated simultaneously, so a NOR gate which generates active high pulse which gives you input output chip select pulse. Okay, and this pulse, then we have connected this pulse with the enable pin of this latch, or which was G pin. So there was one pin which was active low pin output control. So you have plus 5 volt VCC, then you have a ground pin. Okay, and then we have 8 pins for input D0 to D7, and there are 8 outputs. Okay, so Q1 to Q7. So this to the output of the latch we have connected LEDs using the current limiting resistors. So all the nodes of the LEDs they are connected to plus 5 volt. So we have said that in order to make any LED glow, so its output, the output at the data at the output of the latch for that particular LED must be set to 0. Okay, so if you suppose set this pin to 0 and the rest of the pins if they are at logic 1, so only this LED will glow, the rest of the LEDs they will be not glowing. Okay, so this is how we interface. So the address for this circuit is FFH. So you can load this accumulator with any data. Suppose if I write MVIA comma 01H, so it will load the accumulator with 8-bit number, that is 01. So it is 00000001. So once you have loaded accumulator with this data, you can move it to a output port. Now the device address is FF, so you can write out FFH, of course, and then halt. So this program will send this data to the output device whose address is FFH. Okay, accordingly, so for those LEDs where there is 0, they will be glow, and where it is 1, so that LED will not blink. Okay, so this is how you can do it. Now similarly, you can use a 7-segment display as the output device. This is, we have connected individual LEDs, so you may connect the LED to 1 or 2 pins only, rest of the pins they may not be required. Okay, so if it is, suppose maybe if you want to design like this a traffic light controller, so you may use only 3 LEDs. Okay, so you have one LED maybe for red color, one LED which may give you green color, and one for your yellow color. Okay, so you can program the processor and you can turn one LED for some time, then you can create a delay, turn on another LED for some time, and so on. So like this you can do. Okay, it means from this latch now in that case only 3 pins will be used, rest of the pins they are not utilized. Okay, so you have to make sure that the data that you are sending, that data must go on those 3 pins only to which you have connected the light emitting diodes, right? Now similarly you can use a 7-segment display as the output device. Okay, 7-segment LED display, you must be aware about this. So you have 7 LEDs which are connected in a particular configuration, so that you can create any number from 0 to F. So you can 0 to then A, B, C, D, E, and F. Okay, so you have 7 LEDs A, B, C, D, E, F, and J. Okay, and you have another point which is called as DP decimal point. Okay, so you have 7 light emitting diodes and one terminal for this decimal point. And if you see, it is basically this 7 segment display. It is available in the form of a integrated circuit, and this integrated circuit has, it is basically a 10 pin IC. Okay, so you have, of course, 7 pins will be used for these LEDs, 1 pin for this DIP point, and the 2 pins, they are used either to connect the LEDs to the power supply VCC or to the ground, depending upon whether it is a common anode or a common cathode display. Okay, so we have 2 types of displays. One is common anode, one is common cathode. Okay. And how the diodes are connected physically, basically in the common anode configuration. So all the P terminals, they are connected together. Okay, in common anode configuration. So you have one LED, 2, 3, 4, 5, 6, and 7. Okay, so all these 7 LEDs, their P types or anodes, they are tied together, and it is basically connected to the power supply, that is plus VCC. Okay, and now to these N types or to the cathodes, you have to apply some data. Okay, so if it is connected to plus 5 volt, all the P terminal, this is common anode configuration. Okay, it means, so it may be this is for, this is suppose the cathode terminal for this segment A, this segment B, C, D, E, F, and G. Okay, and then, so the data from the data bus, it has to be connected to these terminals. So suppose D0 is connected to this pin and up to D7 is connected to this. Okay, so you can have one more for, if it is a, if this LED includes the display point, if you want to connect it, so you can connect it to this also, so DP. Otherwise you can keep this pin as not connected. Okay, if you do not want to display this LED decimal point, you can keep it disconnected from the device. Okay, so this is what is common anode configuration. Okay, so this is a physical connection. Basically all the P types terminals, they are tied together and connected with the plus 5 volt power supply, and to the anode, to the cathodes or to the N types, now you have to send some signal in order to make this LED blink. Okay, so if you want, now in this configuration, if you want to turn any LED on, it means the another signal to this cathode terminal, that must be at logic 0. So if you apply logic 0 here, this LED will glow. If you apply logic 1 here, this LED will not glow, and so on. Okay, so depending upon this configuration, so you can send any data whatever you want to display. Suppose if you want to display 7 on this 7 segment display, it means your A, B, and C, these 3 LEDs, they must be turned on. Okay, so A, B, C, and these 3 must be turned on. It means if this is a common anode configuration, so I must send a signal 0 here, 0 here, and 0 here. So rest of these 4 diodes, I must send a signal 1, and of course this DP, if it is connected or not, that depends upon what you have. So it may be don't care condition or not connected or don't care. Okay, so if I have a common anode configuration, and if I connect this 7 segment display with this latch, okay, and if you send the data from the accumulator, which is this data. So this can be anything, it can be 0 or it can be 1, it does not matter if it is not connected. Okay, so this data will turn these three LEDs A, B and C, and you will get 7 at the LED display. Similarly, you can transmit any data. If you want to transmit, if you want to display 1, so you have to turn B and C on. It means B and C, these must be kept at logic 0, rest has to be kept at logic 1. Okay, so similarly you have common cathode. In the common cathode, what is done, all the N terminals of these diodes, they are tied together. Okay, so for all the 7 or 8 diodes, we connect their N terminals together, and it is of course connected now to the ground. Okay, and to their cathode terminals, anode terminals, you have to supply some signal from the data bus. Okay, so if you say it is A, it is again B, C, D, E, F up to G, and this is your decimal point. So this must be connected to the data bus through this is D0 to D7. It means now in this case, if you want to make any LED turn on, so you have to send a control signal 1 here. Okay, so if you send 1, it will be turned on. Okay, so if you send 0, it will be turned off. Okay, now let us suppose you have some common anode display. So this is given to you, and you want to interface this with your microprocessor, so that you want to display any data starting from maybe 0 to F. You want to display the data on the 7 segment LED display, and the problem is how you interface this. Okay, so of course this display, the 7 segment LED that you have now, it is basically in the form of a chip or integrated circuit. This is my common anode 7 segment display. I want to interface this with the microprocessor, and I want to send some data on this display. How it has to be done. Okay, so it is common anode. It means your all the P terminals or the cathodes for all these diodes, they are connected together. Starting from, they are connected together with the, of course, plus 5 volt power supply. Okay, they are internally connected, of course. So at the output you have one pin which you have to connect with the power supply, right? And now here output you have 8 inputs starting from, so this is for A, then for LED B, C, D, F, G, and last is for decimal point DP. So on this IC, in terms of pin configuration, this is your maybe pin number 5, then you have pin number 10 for G, similarly pin number 9 for F, 1, 2 and so on, and this is pin number 7. So 8 pins are utilized here, and 2 pins which are left, that is pin number 3 and 8, so they are tied together with the plus 5 volt. Okay, so it is A, B, C, D, E, F up to G. So any number that can be displayed on this, now depending upon what signal you send from this accumulator to this. But before that, you have to interface this with the microprocessor. Now the interfacing is same what we have done like in digital LEDs. Okay, it means now what we have to do. So one thing you can do is, there is a problem that is mentioned here. The problem is that you have to design a 7 segment LED output port with device address. The output for this, the device address for the 7 segment display, this must be set to 5FH. Okay, now see, you can do what we have done earlier. If the device address is 5FH, so what I can do is that I can use a NAND gate again here. Okay, so 5F means it is 1 1 1 1, and 1 2 4 it is 1 0 0 1. Sorry, this is 0 1 0 1 1 2 4 5. Okay, it means this now what we want to do, we want to assign 5 FH address to the 7 segment display, which is will be connected to this interface to this processor. Okay, it means this output must be at logic 0 when the input combination is this one. Okay, so how we do that, again A0 to A7, this is A0, it is 1, it is directly connected. A1, which is 0, it must be connected through a inverter. Then A2 is 1, it is directly connected. A3 is again 0, so it must be connected through a inverter. And rest of the pins which are already 1, so they are directly connected with this. Okay, A4, A5, A6 and A7. Okay, so when this combination is now available at these pins, this will generate a logic 0. Okay, for any other combination it will give logic 1. So this is how we have assigned this address 5F now to this 7 segment display. Now what has to be done along with this, you have input output write signal that you will get from the processor, and these two will be combined using a OR gate to generate a input output select pulse, which is active high pulse, this is active low pulse. Okay, and now this pulse will be connected to the enable pin of the latch. So you have latch here now, again 74LS373, sorry, 74LS373 latch. So the G pin or the enable pin will be connected with this input output select signal. Okay, so you have 8 input data lines D0 to D7, then you have 8 outputs Q1 to Q RQ0 to Q8, RQ1 to Q0 to Q7, RQ1 to Q8, whatever you want. Okay, and then we have plus 5 volt power supply here, and 1 pin for ground, and 1 pin is for output control. So it is permanently connected to ground, right? And the output of this latch will be connected to these inputs of the 7 segment display. Okay, so in between you can have some current limiting resistors, right? So this DP, if you do not want to display this decimal point, so you can keep it not connected, and the rest of these pins, so they will be connected with the output of the flip-flops using some current limiting resistors. Okay, so it is 330 ohm current limiting resistors, all are 330 ohm. So it is done like this. Okay, this is how you can interface a 7 segment common anode display with this microprocessor. Okay, now what I'm saying is that suppose I want to display 7 on this display, so what program must I write, or what instruction must I write? Okay, so first I have to identify this device. So the device address is now F5H. Okay, it means whenever you write this instruction out F5H, what will happen? This latch will get enabled. Okay, using this instruction. Now that you know how it is enabled. Now once this latch is enabled, the data on the data bus must be what you want to basically display on the common anode 7 segment display, because that data will basically come here. Okay, now since it is a common anode display and you are connecting Qs, the positives of the D flip-flop, the Q terminal of the flip-flop with the N terminal of this diode, it means in order to blink any particular diode, this must be set to logic, output must be set to logic 0. So if I say suppose 7, if I want to display 7 on this 7 segment display, so A, B and C, they must be at logic 0. So rest should be at logic 1. Okay, so this can be at logic 0, it can be at logic 1, it does not matter if it is not connected. and if you want to connect it and you want to make it blink, then it must be at logic 0. If you do not want to make it blink, it must be at logic 1. Okay, so if I suppose take it as logic 0, so what data should go from the accumulator is, it is 0 0 1 2 4 8, and this is 1 2 4 7, 74H. So if you display 74H on this, so you will get 7 on this 7 segment display. It means before I execute this out instruction, I must load my accumulator with 78H. So this will load your accumulator with 78H. Now 78H is basically the binary code to display 7 on this 7 segment display. Digit 7 has to be displayed, and then you write out F5H. Once you write out F5H, once the processor executes this instruction, so it will identify that it will see that it is the output data transfer instruction to some output device, and the address of that device is 5FH. So as soon as in the last machine cycle the F5 address is placed on the address bus, this circle gets activated. Okay, and once your processor asserts this control signal input output right, so this gate will generate a control signal IO select to enable this latch. The data is already, this 78H is now already available on this data bus, so it will get latched and it is connected to this 7 segment display. So wherever you are getting zeros, so those LEDs will be turned on. Wherever you are getting ones, those will be turned off. Accordingly, you will get 7 displayed on this 7 segment display. Okay, this is how we can interface with this. Now one more thing is that what he has given in the problem, this is one way how you can select this device address to FFH. Now in place of using some logic gates like this NAND gate, if a decoder circuit is given to you and you have the same problem, you have to, in place of this, you have to use a decoder, a 3:8 decoder. Okay, so we have 3 inputs, 8 outputs. It basically gives a, if it is active low output, so there is a decoder which is 74LS138. So this decoder is basically an integrated circuit. How many pins are there? You have, see, 3 pins for this decoding the address, 8 pins for the output. So 8 plus 3 will get how many pins? 11. And then there are 3 more pins which are for enabling. So it has 3 enable pins. One is active high pin and 2 are active low pins. So this I think we have discussed in memory interfacing also, right? So if you see this, this is the IC 74LS138. This is the pin diagram for this. Okay, it is again with the textile instruments. So it is a 16 pin IC. Of course you need 2 for power supply and ground. Okay, so you have one ABC, pin number 1 2 3, they are used to decode this address. Then Y0 Y1 up to Y7, these are outputs from this decoder which are active low outputs basically. Pin number 16 is your VCC, pin number 8 is your ground, and then G2 bar A, G2, G bar 2B and G1, these 3 are basically the enable pins. Okay, it means this pin must be set to 1, these 2 must be set to 0, then only this decoder will get activated. Okay, this is what we have done here. I have not mentioned here these power supply pins, VCC and ground. So here 3 pins for the address decoding, 8 output pins, okay, and 3 enable pins. So this is suppose E1 enable 1, this is enable 2, this is E3. Okay, so these enable pins are basically written, given the name in the datasheet as G1, G2A, G2B. Okay, so these 2 are active low pins and 1 is active high pin. Now the problem is that this decoder is given to you and you have to assign the device address 5FH to this 7 segment display which is connected to this interface with this processor. Okay, now say this decoder has 3 address lines for decoding, but how many address lines are available with you? You have 7 address lines. So you have A7, A6, 5, 4, 3, A2, A1 and A0. Now out of these 7 address lines, of course you can connect 3 address lines with this decoder. So you may connect suppose A0, A1, A2 with the decoder. Okay, and now one of these outputs O0 to O7 that has to be connected with this. Okay, so you can connect any pin, it is up to you now. Now how we have to connect so that this address should be 5fh, that we will see. Okay, so 3 pins we have utilized for this input to the decoder. Now we are left with 5 more pins. Now these 5 more pins they can be used to enable this chip. Okay, so one is E3. So E3 it must be permanently connected to power supply. So I can connect with E3 pin, enable pin as A3. It means A3 will be set now to 1. Okay, similarly you have 2 more pins, E1, E2. So one should be connected, both of these should be connected to ground. So you can see, you can design the circuit anyway. What you can do is something like this also, that now you are left with 4 pins. So 4 pins you are left with, that is A4 to A7. So you can connect them with the NAND gate, and this NAND gate, output of this NAND gate, this can be connected to this enable pins, this as well as this. Okay, now you have to make sure that what should I place on this so that these pins must be active 0. Okay, so suppose I do like this, otherwise you can do anything like this. Okay, it is not fixed. Now A3 I have connected to the enable pin. It means in order to make this decoder active, this must be 1. So this pin now is fixed to 1 logic 1. Similarly, these 4 address pin lines A4 to A7 I have used or combined them using a NAND gate to generate a enable signal which is logic 0, and I have connected it to both these enable pins. It means this should be logic 0 when all the pins they are at logic 1. Okay, it means also I have set now these to 1 1 1 1. These are fixed, so they are again connected to plus 5 volt power supply permanently, right? So all the 5 pins, 5 address pin lines A3 to A7, they are now fixed to plus 5 volt. Now what you are left with A0, A1, A2. So it can be again anything. If you apply a combination, if you apply 0 0 0 to this, your output 0 O0, it will give a low pulse, rest will be high. If you send a signal 0 0 1 here, your output 1 of the decoder, it will send a high pulse, rest will generate a low pulse, rest will be high, and so on. Okay, now depending upon which output you are connecting with this, accordingly you have to set the address here. Okay, so if I connect suppose any address, suppose I connect output 0 of this with this pin. Okay, now this will come from this terminal input. Okay, it means now this should be 0 0 0. Now when it is 0 0 0 here, 0 0 0 here, and 1 1 1 on all the pins, so this chip gets selected and output of this 0 will be active low pulse, it will decode it. So this address in that case will become now F8H, isn't it? But what we want is that the problem is given that you have to assign the address F5H to this device. Okay, so F5H means now we are fixed that this is 1 1 1 1, and since it is 5, so it is 1 2 4, it means 0 1 0 1. So for this bit combination I must get a active low pulse here now. Okay, So it is now, see this, since I have used these three for the address, so it is 1 2 4. It means O5 of the decoder will be used first thing. Okay, because when this is the input combination on the address lines, O5 will give you a low pulse, so that should be connected to this. And A3 is connected to logic 0 now. Okay, so it means I cannot use this A3 pulse here like this configuration. What I have done, let me redraw it. We have used A0, A1 and A2 for address decoding. So now since address we want F5H, it means this should be the combination of the input. So it is fixed to 101. Okay, if it is 101, it means O5 of the decoder will get activated. It will give a low pulse, rest will be active high. Then we have three pins here, two active low pins and one active high pins. Now, and we have left with 5 pins, so 4 must be at logic 1, 1 must be at logic 0. So this is suppose A2 enable, A1 and this is A3. So A2 is at logic 0, so I can keep connected to A3. Okay, so A3 I have set to logic 0. I have tied it with the ground pin. Okay, not sorry, ground pin. A3 has to be connected to this. Okay, and A3, on this A3 we are now transmitting 0, so this will get activated. Similarly A3, so any one of these 4 pins that can be connected to A3, it is to make it 1, so you can connect it to A4. Okay, now this pin which is left active low pin, so I left it now 3 pins, A5, A6 and A7, so they can be connected with a NAND gate to generate a active low pulse. So A5, A6 and A7. Okay, so if you use this circuitry, it will select this device, the 7-segment display, only when the address is F5H. Okay, if the address is F5H, it means you are placing 101 at these pins, your output will be active low. But before that, this chip must be selected, and for that E3 must be kept to 1. So E3 is connected to A4, so on A4 you have 1. Similarly, A2 which is connected to A3, this should be logic 0. And rest of the 3 pins, they are connected to a NAND gate. So when they all are 111, it will give logic 0 signals. So all these 3 enable pins will get activated using this combination only. Okay. So what you need as a hardware to interface a 7-segment display with the processor is, you need a decoder circuit, 3-stage decoder for this case, 74LS138, which is a 16-pin integrated circuit. Along with that, you need here a OR gate. So this is again 74LS02 integrated circuit, and then you need a chip here, this latch here, 74LS373, and of course one common Anode display. Okay, so by interconnecting like this, you can assign a device address 5 after this, and then you can display any number on this 7-segment display. You can display 0, 1, 2, whatever it is. So that depends upon what you load in the accumulator. Okay, so you have to first load the binary equivalent of that in the accumulator, and then you have to transmit it to the output port. To the output port, we are connecting a 7-segment display. So accordingly, whatever is loaded into the accumulator, so that number will get displayed on this 7-segment display. Okay, so you can go through the data sheets of these devices. Okay, it is available online. So I suppose this is 2 input OR gate, the second IC 74LS32. Okay, so it is 14-pin IC, so it has basically 4 independent 2 input OR gates, 1A, 1B, 1Y. So this is, these 3 are for the first OR gate. So A and 1A and 1B are the input to the first OR gate, 1Y is output from the first OR gate. Similarly, 2A, 2B, 2Y, 3A, 3B, 3Y, 4A, 4B, 4Y. So 4 independent OR gates you have along with ground and this VCC. So you must have gone through these integrated circuits when you have gone through this digital electronic course. So by combining these gates and the decoders and this latches, all these integrated circuits, so you can interface a 7-segment display, and you can program the processor to display anything on this. Okay. So next we will see how to interface some output devices, sorry, this input devices like DIP switches with the processor.